Hello and welcome to ICND1 Lab 5, finding the broadcast address and range of addresses in a subnet. This video essentially continues ICND1 Lab 4, which found subnet number 128.200.96.0 with mask 255.255.224.0. This video continues that process by identifying the range of usable addresses and the subnet broadcast address. For those of you using the Cisco Press exam certification guides, this video is probably best used in conjunction with your reading of Chapter 12 in the ICND1 book. This video has both a tactical objective and a strategic objective. The tactical objective is to help you understand how to use a particular process to find a subnet's broadcast address and then easily find the range of addresses in that subnet. Strategically, this video is here to help you learn how to subnet both quickly and with confidence so you can do well on the CCNA exams. Also note that this lab is dependent on the previous lab, ICND1 Lab 4, so if you've not watched that video, you might want to go ahead and watch it now. Next, for context, I need to give you a little bit of background about the specific process that's described in this video. The Cisco Press CCNA exam certification guides describe several processes with which to find the answers shown in this video, the subnet broadcast address and the subnet's range of valid addresses. Now this video focuses on a single one of those processes, namely the process that's used when the subnet mask is a difficult mask and you don't want to use any binary math. Now a difficult mask simply means that the mask has one octet that's neither a 255 nor a 0, which makes the answers a little bit less intuitive. For those of you using the Cisco Press exam certification guides, note that the books oftentimes refer to this particular process as process RP-6C. Next, before seeing the process, let's take a look at this idea of a subnet broadcast address. A subnet broadcast address is one single address in each subnet. When used as a destination address in a packet, causes that packet to be broadcast to all hosts in that subnet. Now, because it's used for broadcasting, it cannot be used or assigned to a host to be used as a unicast IP address. So it helps to see an example. For instance, here, PC2 is going to send an IP packet to address 128.200.127.255, which is the subnet broadcast address of the subnet on the left. So let's take a look at what happens. First of all, PC2 sends its packet, and as usual, PC2 says, all right, this packet is destined to an address in a different subnet. Let me send the packet to my default gateway, in this case R2. R2 makes a simple routing decision and says, oh, the subnet that this address is in is on the left, let me send this packet over to R1. Now R1, when it gets the packet, thinks, this address is actually a subnet broadcast address on the subnet connected to my LAN interface. So when R1 forwards the packet, R1 encapsulates the packet in an Ethernet frame, and R1 sends this frame with the destination address of the Ethernet LAN broadcast address. As a result, the switches in the LAN flood the LAN broadcast, so all the hosts in the LAN get a copy of the frame. In this case, that means both PC1 and PC3 get a copy of the one frame sent by R1. Next, just to be clear, let me define what I mean by range of usable IP addresses. First of all, the subnet number itself cannot be assigned to a host to be used as its unicast IP address. And as we just saw, the subnet broadcast address cannot be assigned to a host either. However, all the numbers in between the subnet number, which is the smallest number, and the subnet broadcast address, which is the largest number, all the numbers in between there can be used. For instance, this video shows an instance with a subnet number of 128.200.96.0 with a mask of 255.254.0. Now it turns out the subnet broadcast address in this case then will be 128.200.127.255. So the first assignable address is simply one bigger than the subnet number, as you see here, and the last assignable address is simply one less than the subnet broadcast address, as you see here as well. For easy reference, the screen now shows a copy of the text of the process that will be demonstrated in this video. Notice that this process starts with step 5, and it's numbered this way because the associated process that finds a subnet number has 4 steps, so this process just picks up where that other process stops. Next, we'll start where ICND1 Lab 4 stopped, which is to say we have subnet number 128.200.96.0 listed in a table. the interesting octet identified, the magic number calculated, and now the table's been expanded to have room for the first IP address and last IP address in the range of addresses, as well as space to write down the subnet broadcast address. So to begin, we start with step 5, and step 5a in particular says, look at the mask octets whose value is 255, or visually, look at the octets to the left of the rectangle. For those octets, we simply copy the subnet number's value down to the broadcast address. Simple enough. Then for any octets fully to the right of the rectangle, or octets whose mask value is 0 if you prefer, we're going to write down a 255 in that octet of the broadcast address. So in step 5a, we copied the subnet number octets, and in step 5b, we wrote down 255s in the octet to the right, leaving a single interesting octet to figure out the value for. At step 5c, to figure out the broadcast address's value in that interesting octet, we take the subnet number's value in that octet, add the magic number, and subtract 1. The math obviously is pretty simple. We end up with a 127 in that octet, which gives us the final answer of broadcast address 128.200.127.255. Next, for completeness, I'll show the very simple math about how to find the first IP address and last IP address in the range of valid addresses. Step 6 of this process says to find the first IP address in the range of valid addresses, start by copying the first 3 octets of the subnet number. Doesn't matter where the rectangle is, just copy the first 3 octets and then add 1 to the 4th octet of the subnet number. So as you see here, you take 0 plus 1, of course, is 1, giving us a first valid IP address of 128.200.96.1. Step 7 finds the last valid IP address in the range of addresses based on the subnet broadcast address value. For step 7, similar to step 6, we copy 3 octets, but in this case we copy the first 3 octets from the subnet broadcast address. Then for the 4th octet, you simply subtract 1 from the broadcast address's 4th octet. In this case, 255 minus 1, of course, is 254, which gives us a last valid IP address of 128.200.127.254. This concludes this video's example of how to use process RP-6C to find a subnet broadcast address and range of valid addresses. However, before finishing up the video, I need to let you know about a couple of the IP addresses in that range that may cause you problems when you look at it on the test. In particular, consider the addresses you see here: 128.200.96.255, 128.200.97.0, 97.255, and 98.0. Many people might look at those numbers and instantly think that the ones that end in 0 are subnet numbers and the ones that end in 255 are subnet broadcast addresses. Well, all these numbers are valid assignable IP addresses. You can configure them on hosts in the subnet that we just looked at, and they work just fine. So try to resist the temptation to make assumptions about dotted decimal numbers, particularly because not all numbers that end in 0 are subnet numbers, and not all dotted decimal numbers that end in 255 are subnet broadcast addresses. This concludes ICND1 Lab 5. This video has demonstrated a process by which you can find the range of valid addresses and subnet broadcast address for a given subnet using no binary math. More importantly, it's a tool that you can use when taking the CCNA exams to more quickly and more confidently answer subnetting questions.